The InnoTamp project was an application into the First of a Kind 2020 competition sponsored by DFT and delivered by Innovate UK. It combines state-of-the-art geolocation technology with intelligent tamping, bringing the two together to really give a state-of-the-art capability to put the track where you want it and to give the best ride quality possible.
It's been great to have Fugo working with us at these times, and they finding new and novel ideas to help us. These digital sets have the potential to revolutionise the way we maintain our network. The data is quick, it's accurate, it's reliable, and we can use it again and again.
Tamping is a really important routine maintenance activity that we carry out on the railway. Tamping the track corrects the track geometry, reducing the likelihood of derailments, and creates a smoother ride for passengers and freight. Within InnoTamp, we're looking to facilitate design tamping. This is different to maintenance tamping in that it allows us to design the track position. To design the track position, we need to understand where the track is in 3D space and how it relates to the surrounding assets, such as bridges, overhead electrification, and the adjacent track. With all this information together, we can create the optimum alignment. Once we've got the alignment design, we can convert that into a tamper file. This is the file that has the required lifts and slews to move the track from its current position to the designed position. This file can then be loaded onto the tamper, and the tamper can go to site and do its job. Unlike maintenance tamping, the tamper doesn't even need to collect a pre-tamp run. It can just go to site and start tamping straight away. What is different about InnoTamp is that we collect the data via Ryler. In conventional design tamping, we'd have to send survey crews out onto the track to collect data. Using Ryler, we can collect that data from passenger trains without disrupting the network.
The potential list of applications for the data is endless. We can start looking at adjacent line opening, signal sighting distances, distance to access points, visibility, the list goes on. And all this is achieved from the safety of being at home or even being at the office.
We can also determine the existing ballast profile from the Ryler data and use it to accurately determine the tonnages of ballast required to achieve the designed track lift, and determine if the ballast profile after the track lift will still be within specification. This significantly reduces the potential for the track lift not being achieved due to a lack of ballast on the site, and avoids locations being over-ballasted, which reduces the ability of other automated inspection systems to identify missing track components such as clips. The key benefits that InnoTamp will deliver is the ability to design TAMP at an affordable price without having to put surveyors and engineers on the track. This means we'll be able to optimise the track alignment, creating an even smoother ride for passengers and freight, and consequently, the maintenance costs for both the infrastructure and the rolling stock will reduce massively.
The reduction of boots and ballast time during data collection has been fantastic. This has proved that the Ryler technology is safe, reliable and accurate. It's all brand new to us, and we don't know which way it's going to go in the future. But hopefully by using this data the right way, the most efficient way, and putting the right technical knowledge behind it, it can really be a game changer.